say something like, occasionally you might see this written as an x, so x plus 2 equals an unknown number like y or something like this. But we're using letters instead of numbers here. And this tends to throw a few people, so don't get too scared when you first see them, because we much treat these letters the same as we treat numbers in normal mathematics. So I'll give you an example of this. Say we have something like a rectangle, and I'll show you how we can do a algebraic example here. So we had a rectangle here, and we knew that the side length here was 7 centimetres and this side length here was 3 centimetres. Okay, well, say I said I wanted to work out the perimeter of this. Well, the way we'd do it is as follows. Okay, we'd get this perimeter, this PE equals, and it'd be equal to 7, this side here, as well as this side here, so plus 3, plus this side here, plus 7, plus this side here, which is 3. Okay, so altogether that would be 20 centimetres. And that's all well and good, and it's not too bad, okay, that's fairly easy. And all we're doing is we're adding the sides together, but what I'll do is I'll actually get rid of these numbers now, and I'll write it slightly differently. So say we actually don't give you the actual side lengths here. Instead I actually give them as, I'll give them as something that can change. I'll give the length here as an L, and I'll give the width here as a W. And now I say I want you to work out the perimeter. Okay, so we actually haven't got the length and the width stated here, but we can still actually show a relationship to work out the perimeter, and it's as follows. So the perimeter, well, it would be equal to, like we did before, we've got a length and a width. Okay, so the length plus the width plus this length plus the width. Okay, so we could actually take that a step further. We could say we've got two lengths. Okay, I'll put a little L there. I think maybe that will make it a bit easier to see there. Okay, so we've got two lengths and we have two widths. So all of a sudden what we've done is we've written this as an algebraic expression, okay? Instead of actually putting numbers there. And a bit later on what we might do is we can actually substitute values in here where we said, say, this length here is 7. Okay, so 2 times 7, and this one here was 3, so 2 times 3. And again, if we do that, 2 times 7 is 14, 2 times 3 is 6, and we end up with 20 centimetres. But this way here is written algebraically. So this algebraic expression has two terms here. It has this L and this W, okay? And they also have this thing here which is called a coefficient in front of them. Both have this coefficient of 2. The number in front of the algebraic expression, what we might call a variable, is called a coefficient. So that's an example of, say, something algebraic. So from here what we're going to be doing is we're going to start actually having a look about how we can actually write certain algebraic expressions and then how we can simplify them. Okay, so it's a really, really good thing for you to be able to get the hang of before you start then launching into later algebra. So say for instance what I wanted to do was I wanted to actually write 4 times a number. Okay, so how could I actually write 4 times any given number here using algebra? So what we could do here is, first off what we're going to do is we're going to replace the word number, 4 times a number, we're going to replace that word number with x, so 4 times x. So we've changed it to a letter here. Okay, so 4 times x. We can actually write this, we don't bother put the times in here a lot of the time. What we start to actually do is we write this as 4x. So if you start seeing algebraic expressions like this, 4x, what it actually means is 4 times a given number. Say x was, for example, 3. Okay, 4 times 3 would be 12, or say it was 7. 4 times 7 would be 28. Okay, so x can change here. So I'll give you another example. Say I wanted to write 5 times a certain number. How would I write that? I'd write that 5 times, and you can choose any letter here. Do I have to use x? No. I might use a here, but you might have used x. Okay, so 5 times a, and we get 5a. Now it doesn't actually matter what actual letter we use with this, okay? Often we'll use x's and we'll use y's and we'll use a's and we'll use b's. But it's just mainly fairly a good thing to actually do is to actually try to be a bit consistent with these. And I also try to use letters that often don't get confused with numbers, like I think using L or something like an O can be very confusing because it could look like a 0. Okay, so another thing when we're doing algebra is we can also add certain algebraic expressions together, ones with like terms. And these are ones that contain exactly the same pronumerals. I'll show you what I mean by this, okay? Say I had, say, something like 4x plus 5y plus 2x. Okay. You're going to see here that we actually have a couple of these pronumerals here are the same. We have this 4x here and we have 2x here. We can actually group these together, okay? So what we can do with these is 4x plus 2x. What we can actually do is we can group these guys together, so 4x plus 2x is 6x because we're adding them together. Okay, so 4x plus 2x is 6x. And 5y you're going to see is different. We can't actually add this to 6x. It's a different pronumeral, so we can't actually group that in with that. So we actually put this over here as just plus 5y. Okay, this is a way that you can actually simplify algebraic expressions. So number one, what we can do, this means 6 times x, and we can put those together. But we can also add ones with like terms together. Ones that are not like terms, we can't add together. And I'll give you another example of an unlike term, which is a fairly good one to be able to understand. Because it's another good thing that you sort of get is that the actual the powers of the term also matter. And I'll show you what I mean by this. Say I had, say, something like x squared. This means x times by itself. And I add this to 8x. And I take 5x. And I add 2. And I say I want to simplify this expression. So what I want to do is group any of the like terms together. Now you're going to see here we've got x squared, we've got 8x, negative 5x, and we've got 2. So first off, we can actually say this negative 5x and this 8x here can be grouped together. But what about this x squared here? And unfortunately, we can't group these guys together because this is a different power to x here. Okay, so you can't group these guys together. So they have to be of the same power. So if it's x to the 2, you can't add it, and if it's x to the 3, you couldn't add it. So we end up with the following. We end up with this x squared, and we're going to add 8x take away 5x. So 8x take away 5x is 3x, and then this 2 here, plus 2, also can't be grouped. So we end up with this sort of expression. Okay, I'll give you an example which I'll get you to answer by yourself. So what about a couple of these? So I'm going to get you to group these sorts of questions here. So I want you to group up 3y plus 2x plus 4y. How would you go about grouping those? Okay, so hopefully what you're going to do is you're going to realise that we have the same pronumeral here, the same letter here in y, 3y and 4y, so we can group these guys together. 3y plus 4y is 7y, and here we have this 2x, so you can't be grouped any further, it's a completely different letter, so we end up with just place 2x. Okay, and it seems a little bit strange at the moment. Okay, and you might actually still get that this means 7 times y, and it's plus 2 times x. Okay, it's an important thing to understand also. And also, what we'll eventually do a bit later on is we might give y a value. We'll say, say we said y equaled 3 and x equals 2. What would our expression equal? We might do that. Okay, that sort of thing does happen in math. So if y was to equal 3, 7 3s are 21, plus x equals 2, 4 equals 25. Okay, so that's the sort of thing you might be doing in algebra. Okay. Okay, what are we going to head on to next? So we can also multiply and divide occasionally when we're talking about unlike terms. Okay, so we can add and subtract like terms. We can actually multiply unlike terms, and I'll show you what I mean by this. Say we were to actually say what is 6x times 3y. Okay, we were asked to simplify this. Now, with this, what you might realise is, okay, they are different, they're unlike terms. We can actually multiply these, and I'll show you how to do this. 6 times 3 is 18, so we actually multiply these coefficients as normal. Also on top of this, because if I actually write this is 6 times x times 3 times y. Okay, so 6 times 3 is 18, We also timesing by x, okay, and we're also timesing by y. So we end up with 18xy. This means 18 times x times y. Okay, so we end up multiplying these expressions together. So when you're first doing these, it's probably not a bad idea to actually write them out the long way until you get used to actually doing this. But you can actually do this. So I'll give you another example for you to go and say I asked you to multiply 5x times 3y. Okay, so you might write this as 5 times x times 3 times y. Okay, there's two numbers here, the 5 and the 3, we can multiply each other. We get 15 times x, so we just put the x there, times x, times y. Okay, because this here, they're sitting next to each other, it just means they times one another. So 15xy. Another type of multiplication we can do when we do algebra, geez, there's so many of them, isn't there? But they're not too bad, you do get used to them, is this sort of thing. So we actually had 4x, and I wanted to multiply this by x. Okay, how would you go about doing this? Well, with this, it's kind of a funny thing, but what you might realise is this is equal to, again, at the start when you're first doing this, you might write this as 4 times x times x. Now, if I was to put a brackets around here, this x and this x here, you're going to realise possibly that this is equal to x squared. A number times itself is said to be squared, okay? And then what we have is we have this x squared and we multiply this by 4. So we end up with 4x squared. I'm about to give you one of these. What about we do 3x times, what about, I won't do this x, I'll even go a step further, I'll do it times 4x. So first off, write it all out. So we have 3 times x times 4 times x. Okay, so first off we can do 3 times 4, which is 12, times x times x. So x times x is x squared. Okay, so we might even write at the start x times x when you're first working these out, and then you realise that this here is x squared, so it equals 12x squared. And when you're first doing these, you might get a few of them incorrect, and it might be a bit of a bit hard when you're first starting, but don't get too despondent with it. You do get used to them. What about just one more like this? What about we do a bit of a more difficult one? What about I do say something like minus 2xy, and I'm going to multiply this by 3y. Okay, it's a pretty difficult one, yeah? Again, so what we start off doing is we'll write equals, and it equals minus 2 times x times y times 3 times y. Okay, so we've written it all out this long way. Okay, so first off, let's multiply the coefficients. So we've got minus 2 times 3. Minus 2 times 3 is minus 6. Okay, we have an x here, so I'll put that down. We have an x, so we're timesing by x, and we also have two y's, so y times y. So this is y times y, which is y squared. Okay, I'll tell you what I'll do with this. I will give you a bunch of examples here right now to go through, and we'll see how you go with these, okay? And then we'll answer these. So that was a whole big lesson on that, and I think it's a really, really difficult one when you're first starting out, but don't feel too bad with this, okay? Because if you can get those, you pretty much will work out a lot of the algebra without much sweat. So what about first off, we'll start off very simply. Can you simplify these sort of things? So I'll put up 5 questions. 1, 2, 3, 4, 5. Okay, so the first one I'll put up is as follows. What about I get you to simplify 3x plus 2y minus 2x. What about this one here? Well, we'll go x squared plus 3x plus 2x squared minus y. Okay, what about this one here where we'll go, what is 3x times 4y? What about we go, what's 3x times 2x? And last of all, what's minus 2y times 3xy? Leave it there, okay? So we'll give that a go. So pause it, give it a go, see how you go. We'll work through these particular answers. Okay, so how'd you go? Did you pause that, or you just didn't pause it at all with your go? Let him work it out for me. Anyway, hopefully you pause it and we'll see how you do. Anyway, first off, we'll get to this first question. 3x plus 2y minus 2x. So first off, we had to recognise these like terms, and these are the ones with the same pronumeral, the same letter. 3x, take away 2x, is x. Okay, and we're left with plus 2y. Okay, so hopefully you got that answer. What about this next one? I'll underline the ones with the same coefficients and to the same power. So we have x squared plus 3x plus 2x squared minus y. So x squared plus 2x squared, we have 3x squared. Then we have plus 3x, which is by himself, plus 3x. And we also have minus y, which is also by itself. So we're going to not be able to do much more with those. So hopefully you went well with that. What about this number 3? 3x times 4y. Okay, so this is going to be equal to 3 times x times 4 times y. Okay, so 3 times 4, we multiply these coefficients and we get 12. And then we get the x there, and then we've also times in the y there. So 3 times 4 is 12, times x times y. Okay, what about this next one? 3x times 2x. So first off, I'll multiply these coefficients actually. So we're going to end up with 3 times x. First off, I'll write the whole lot out. 3 times x times 2 times x. Coefficients, 3 times 2 is 6. And then we have x times x. So x times x is x squared. How'd you go with that? And last of all, we have this minus 2y times 3xy. So again, first off, I'll write them all out. Minus 2 times y times 3 times x times y. First we multiply these coefficients, these numbers. So minus 2 times 3 is minus 6. Hopefully you got the minus 6 there, yeah? Yeah, that's a bit of a trick there. And we've got 1x, so I'm going to put that down. And we have y times y, so we have y squared. Minus 6xy squared. You know, it actually doesn't matter also if you've ever written it a different way. If you've written it minus 6y squared x, it's exactly the same number. Okay? It still means minus 6 times x times y squared. And this one also has minus 6 times x times y squared. It's just written in a different order. Okay? It's like this one up here. If you had written this as 12yx, it's exactly the same number. I just tend to put the x's before I put the y's. Okay, it's just a bit of a habit I've got into. Anyway, hopefully that was of some use to you. In future videos, what we're going to be having a look at is we're going to start actually taking this a little bit further, where we're going to start expanding and working out different factors and things like this with algebra. So we're going to make this algebra a little bit more complex. Anyway, I hope to see you then. Bye.